Hello everyone. In this video, we will see all the intermediate and advanced problems of divisibility and factors. Okay. So in our previous video, we saw all the primary, basic uh, problems of divisibility and factors, right? So first of all, we will start from the perfect number check. Okay, perfect number checking programs, guys, right? I hope you already know what perfect number is. So if you don't know what perfect number is, I'm just going to describe you again, right? So let's say you have a number 6. 6 is a perfect number, guys. So this is for what? Okay. So if you think about the numbers which can divide 6, first of all, 1 is there. 1 can divide 6. 2 is there. 2 can divide 6. 3 and 6 can divide 6, right? So we will exclude 6, not the number itself, right? We will exclude 6. So if you add them 1, 2 and 3, you get 6 again, right? So these types of numbers are called perfect numbers. So here we have a program that will help us to find a perfect number. This program can check if a number is perfect or not, right? Let's okay. So here we have the program. We are taking input from the user, and we have a variable, sum variable, right? And it has value 0, right? So I hope I don't need to describe these things again. And we have a for loop, guys. Okay, so and this for loop starts from 1, and it goes up to the number, right? So less than the number. So as it starts from 1, so we can just check, if we want, we can less than or equal to number divided by 2, we can do that too as well. And we don't want to just divide by the number itself, right? So we are excluding 6 divided by 6, but all other numbers, like all previous numbers, should be should be given a chance to check if they can divide or not, right? So anyway, if number modulus I equals 0, whatever the number modulus I is 0, then that means if it's evenly divided, then we will increase the sum by the I, right? So sum is 0, 0 plus I, that means sum would be 0 plus 1, sum would be 1, right? And then I will increase, and for 2, okay? So 2 modulus 6, more 6 modulus 2 is 0, so sum would be increase again. So this is how it will work, guys. And then and after all iterations, after it terminates, we will come here. If sum equals number, then we will say that it's a perfect number, otherwise it's not, right? So this is, we discussed these things before as well, so we're not going to waste any more time here. Okay, so 6 is a perfect number. So if you provide any other number like 10, it's not a perfect number. So next perfect number is 28, guys. Okay, so 28 is a perfect number, and next one maybe 496 or something. I forgot. 496 496 is a perfect number, yeah. So anyway, and our next program is common divisor of two numbers, guys. Okay, so we will get two numbers, and we will see which numbers can divide both of them, right? So uh, you can say, let's say 4 and 8. Okay, so what are the common divisor of 4 and 8? Okay, so 1 can divide 4, 2 can divide 4, and 4 can divide 4. uh, and okay, so what are the common divisor? 1, 2 and 4, right? So 8, uh, 1 can divide 8 as well, 2 can divide 8, and 4 can divide 8. So this is what happens, guys, which are the common divisors of two numbers, right? So we will take these two number from the user. right? And we are declaring these variables too, and we have a variable minimum. Okay, so in this minimum variable we are just we are just storing the minimum number, the smallest number of both of them. Okay, so let's say 4 and 8. So in this case we're saying number 1 is less than number 2. Okay, so if this condition is true, then number 1 is the smaller number, and it should be stored in this minimum. So what this this question mark means, this is ternary operator, guys. This means whatever after question mark will be implemented if this condition is true, right? So here our condition is true in case of 4 and 8. So this number 1, 4 will be stored here, right? So otherwise number 2 would be stored here. So if you want, you can you can take 8 in this number 1 and 4 in this number 2. So whatever you do in this case, number 2 will be stored. So number 2 will be 4, 4 will be stored. So whatever you do, the smaller number will be stored. Okay, so now printf common divisor of these two numbers, so number 1, number 2. Okay, I hope you understand this. And now for loop. Okay, so I starts from 1, I is less than or equal to minimum. Okay, so we don't need to go beyond minimum, guys, because you know uh, if you beyond 4, then 5, 6 and 7, uh, these numbers can't evenly divide 4. Okay, so uh, you know uh, checking up to a minimum number is fair enough, right? So if modulus I equals 0 and number modulus I equals number 2 modulus I equals 0, so these two should be evenly divided by I. Okay, so I will be increased every time, guys. So now we will print the I, right? So this is how we will get the common divisors, right? So let's say 4 and 8. You see 1, 2 and 4. Okay, our next program is divisibility check using modulo, guys. Okay, so what it actually means we will see in this program, right? So we are taking input from from user. We're taking a number from the user, and we have some variable 0, temp and digit, right? So let's see why we need temp and so temp is storing number. Okay, temp is getting the number, so whatever number user provides, right? So while temp not equals 0, so not equals 0, it will come into this part, right? So we know how to get the digit. Okay, so if you divide any number by 10, we will get the last digit. Okay, so let's say you want to take 123. So if you divide by 10, so it will go 12 times 120, and the rest 3 will be reminder, and that rest 3 is being stored in this digit. Okay, so now sum would be 0 plus digit. So 0 plus digit means 3, and now temp will be divided by 10. So temp is 123 in our case, and it's divided by 10, right? So we are getting 12 here. So this 12 would be stored in this temp again. And for the second iteration, so I hope you understand, guys, I showed you this many times, right? If number modulo sum is 0, then uh, is if we can after adding all the digits. So if number modulo sum is divisible, then we can say this is divisible. Okay, so especially this kind of thing is we check if any number is divided by 3 in this way. Okay, uh, no, no, I'm sorry. Okay, so we are just adding the digits, and we're just just we're just doing an addition operation in the digits of the number, right? And then we are trying to uh, trying to check this result of this addition can divide the number, right? I hope you understand this program. So now we will see a program, guys, and this is product of factors, right? So whatever the factors we have for a number, let's say 24. So there will be so many numbers can divide 24. Okay, so we will just multiply the products only. Okay, So now multiply the factors only. Okay, so and then we will see what number we get. Okay, so you see, product, here product is, long type, guys, because if you multiply, then you may get if you multiply 3 or 4 numbers, or maybe 5 numbers, you may get a huge number, right? Big number. So this is why we are just taking long type of uh, variable, right? So you see here, uh, for integer I equals 1 and I is less than or equal to number I plus plus. So here we are doing product into I. Okay, product equals to product into I. So product in whatever the product is, in the beginning, product is 1 into I, that means 1 into 1 would be stored in the next iteration. 1 into 2 would be stored in the next iteration. So this is how it works, but the condition is number should be evenly divided by I. Okay, I hope you understand. If you don't understand, type the code and try to visualize as we usually do, right? So today I don't want to waste any more time, guys, here. So I hope you understood these programs, and uh, thank you for watching this video. See you in the next video, guys. Keep practicing, and we will just, we should finish all the math topics as quick as we can, and we need to go in real coding, right? Real projects. Okay, thank you for watching.